Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Shahmi bin Muhammad Yusof. My matrix number is DE210091. I'm from Group 7, Section 1. Okay, so today we will present about our group project, which is Mini EV Prototype Project for Subject Electric Drive, BEV30703. Okay, our group consists of 5 members, which is me, Muhammad Hazim Shahmi bin Muhammad Yusof, Syarul Adli bin Zulfikar Husni, Muhammad Farid bin Samsul Kahar, Ishak Syahmi bin Rus Husaini, and Nick Hairul Hazril bin Nick Fazil. For introduction, first I will explain about what is EV. EV is electric vehicles or plug-in cars. They are at least partially powered by electricity. There are a lot of examples for EV such as full cell electric cars, plug-in hybrid electric vehicles, and battery electric vehicles. Okay, EV are more ecologically friendly option. Okay, so next is what is a DC motor? A DC motor is an electrical mechanism that transfer electrical energy into mechanical energy by producing a magnetic field that is driven by DC or direct current. Okay, DC motors are favored over other kind of motor because they can easily adjust their speed. So how they adjust the speed is the speed of DC motor can be easily adjusted or controlled by adjusting the potentiometer voltage within the motor's safe working range. Okay, next is the project background. Okay, this project aims to introduce students to the practical application of electrical engineering. This project also focuses on the design and development of a speed control system for DC motor which are utilized in small electric vehicles or what we call EV. Okay, next is the scope of study. Okay, the scope of this project encompasses several key areas of focus in developing a speed control system for a DC motor used in EV prototype. Okay, there are 5 key areas of focus, which is the first key is circuit analysis and selection. Second is design and development. Third is implementation of control strategies. Fourth is prototype construction. And the last key area of focus is testing and optimization. Okay, next is the objective. There are 3 objectives for this project, which is the first one is to achieve precise and responsive speed control at different level, potentially with smooth transition. The second objective is to efficiently control the DC motor by implementing an L298N motor driver. The third objective is to assess and compare the performance of mini EV prototype model to achieve optimized DC speed control with high efficiency. Okay, for literature review, we have done a lot of research from previous study. For example, the first paper is regarding the DC motor speed control analysis. Okay, in this paper, they explain that numerous traditional controller tuning techniques will result in significant rising time, settling time, overshoot, and steady state inaccuracy. Okay, the result from this paper is hybrid controller combines many control strategies to provide the best possible answer for control issue. Okay, the second paper explain about the control of DC motor. Okay, in this paper, they explain that the DC motor may be equipped with a few controller, and the most widely used controller is the PID, since it is very straightforward and simple to integrate. However, the PID controller have several shortcomings, and to counter that, the integrated state feedback is an alternative controller for tracking control in DC motor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Irsyad Syahmi bin Rus Husaini. My matric number is DE210109. Okay, next part is for design and control methodology. First one is flow chart. Okay, we start and then connect Bluetooth on the Bluetooth RC control application. If the Bluetooth cannot be connected, try again until it be connected, and then proceed to the control mini EV prototype using Bluetooth RC controller, and then control speed of the mini EV prototype, and then end. Okay, next for block diagram, the microcontroller is the main component which control the Bluetooth module and motor driver. So Bluetooth module we connected to the application which can control the mini EV via Bluetooth, and then the Bluetooth module will send signal to microcontroller, and then microcontroller will control the motor driver to control the both right and left motors. The battery will supply the battery for motor driver, and then supply also to the microcontroller. Okay, next for the circuit we use in this project, the Arduino Uno will connected to the Bluetooth module and motor driver, and then the DC motor will connect to the motor driver, and then the battery will supply the motor driver and the Arduino. Okay, next move to the control method. The left figure is the interface of the Bluetooth RC controller application, which this application is used to control the mini EV to move forward, reverse, turn right, turn left, and control the speed. In the right figure is the method that we use to carry out the speed test for the mini EV. We have set a track from point 1 to point 2 in a length of 1.5 meter. The car will be moved forward from point 1 to point 2 and then immediately move reverse from point 2 to point 1 to complete a lap. The time for the mini EV to complete a lap will be taken. The speed test will be run with the initial speed and 50% speed and then 100% speed of the mini EV by adjusting the indicator on the top right corner at the application interface. By drag the indicator from 0, half and full speed. In order to determine the speed, we will calculate it with using the speed formula, which is speed is equal to the distance of mini EV move from point 1 back to point 1 over time taken to mini EV complete a lap.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Shamsukaha and my number metric is DE210095. So I will continue the presentation for the outcome of the project. In our project report, we meticulously detail the process of analyzing and selecting the most suitable converter or driver circuit for controlling the speed of the DC motor in our mini EV application. After considering various technical specifications and performance requirements, we chose the boost converter due to its availability to meet our speed control needs and voltage compatibility. Additionally, our report showcased the successful demonstration of the electrical drive system using the Arduino microcontroller, DC motor drive, and speed controller. We provided a comprehensive overview of the system setup, the method used for speed control and direction, and the challenge we overcame during the demonstration. Furthermore, we emphasize the collaborative problem-solving effort within our group, highlighting specific challenges encountered, our collective problem-solving approach, and the valuable teamwork and problem-solving skill developed throughout the project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nia Hairul bin Fazil. My number metric is E210045. So, I will explain about our result and discussion. So, our main components are Arduino Maker Uno, motor driver L298, and Bluetooth module HC05, DC motor, and lastly battery 9 volt. Okay, Arduino Uno is a microcontroller board that acts as the brain of the project, executing code and controlling other components. L298N motor driver act as interface between the Arduino and motors, allowing control of the motor speed and direction. It also helps protect Arduino from high motor currents. The Bluetooth module enables wireless control between the Arduino and other Bluetooth RC controller applications. The DC motor is the main part where it will convert electrical energy into mechanical motion to drive wheel by rotating in a forward or reverse direction based on applied voltage. Last but not least, the battery will provide power to the Arduino, motor driver, and motors. Okay, next is the result of speed in application, time taken, and the mini speed. So for the speed initial, the time taken is 0.95 seconds, and the speed for the mini EV is 0.38 mph. While for the 50% speed in application, the time taken is 6.59 seconds, and the time is 6.59 seconds, and the speed is 0.46. Lastly, for the 100%, the time taken is 5.97 seconds, and the speed is 0.5. So this is our specification for the project. Okay, for the first one, rated voltage is 3 to 6 volt. Continuous no load current 150 mA. Minimum operating speed 3 volt is 60 plus minus 10% RPM, while minimum operating speed 9 volt 200 plus minus 10% RPM. For the torque is 0.15 Nm to 0.6 Nm. Stall torque is 0.8 kg per cm. The gear ratio is 1:48. Body dimension 70 multiplied by 22 multiplied by 18 millimeter. So for the wire length, it is 15 centimeter. Weight 30.6 gram. Chassis size 215 mm multiplied by 150 mm. For the wheel diameter is 67 mm. Caster head 34 mm. Lastly, the dimension is 215 multiplied by 150 multiplied by 67 mm. Okay, for the analysis, the first one is effective speed control. The Bluetooth RC controller application successfully control the mini EV's movement and speed, demonstrating the functionality of the chosen boost converter and driver circuit. The second one is positive speed-time relationship. The recorded data reveal a clear positive correlation between speed setting in the apps and the actual speed of the mini EV. The last one is speed responsiveness. The mini EV responds accurately to change in speed settings with noticeable difference in lap times for different speed level. Okay, the next one is initial speed. The initial speed of 0.38 mph indicates a slight delay in acceleration, potentially due to factors such as motor starting torque or app-to-motor communication delay. Further investigation is warranted. Speed variation. The speed increased as expected with higher app settings, reaching 0.46 ms at 50% and 0.5 ms at 100%. This confirms the effectiveness of the speed control system.
Okay, now we will doing test speed at initial speed. 1, 2, 3. Okay, next we will test speed at 50%. 1, 2, 3. We will test speed at full speed. 1, 2, 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syarul Adli bin Zulfi Kausni. My number is DE20106. So I will be presenting the conclusion. So this project is designed and implement a DC speed control system for a mini EV. Prototype has been resounding success. By integrating an Arduino Uno microcontroller with an L298N motor driver, this project resulted in achieving precise and responsive speed control, allowing for smooth transition at various speeds. So the L298N motor driver in particular proved to be an effective choice for this application, offering a balance between complexity and functionality, making it accessible for educational purpose while still providing the necessary capabilities for robust speed control. The project not only met its objective to create an efficient and reliable control system, but also provided valuable practical experience. Through hands-on design, development and testing and optimization, the project has bridged the gap between theoretical knowledge and real-world application, preparing for future challenges in electrical engineering.